All right, good morning and welcome to our August learning series. My name is Wayne Welk, an automation specialist with the Reynolds Company out of New Orleans, and I'm just going to quickly introduce our topic and our kind of upcoming events like we typically do. As you just heard, this session is being recorded, and we do make it available afterwards on our YouTube channel. Everybody's lines are muted, so if you want to ask a question during the session, we invite you to use either the chat panel or the Q&A session. And then at the end of the session, we can unmute your line if you'd like to ask a live question, but maybe we'll hold those to the end. But feel free to chat a question in at any time. We've got several other specialists and team members in the background that'll help kind of answer those questions along the way. So our topic today, PlantPAx and the new 5015 FLEXHA 5000 IO. It has a mouthful to say, but we will introduce it and talk about what it is and what makes it special. So as we typically do, we like to talk about what's coming up and also highlight what we've done in the past. The gray boxes are what we've done in the past, because again, all of these sessions have been recorded and they're available on our YouTube channel. So if you missed one, and want to go back and watch one of these topics, please, we invite you to do so. Being that we're in August, we only got 2 more learning series topics on our schedule for 2023. Believe it or not, we're at that point of the year. So we have in September, we're going to do a Factory Talk software update. And then in October, we'll look at Automation Fair and do a preview of what's to come at this year's Automation Fair. And then our tech talks are continuing as well throughout the end of the year. We will actually do one in December. It's just not on this chart. But this month, we have a tech talk with Hoffman around thermal audits. That's going to be a pretty interesting discussion and presentation. And then September, we'll have Cooper Lighting, talk about some of their solutions. And then in October, we'll have HMS with an update on their products, which are, includes Anybus and Ewan are part of their products. And like we've been doing all throughout this year, we've been highlighting Automation Fair 2023. This year it's in Boston and it's coming up in November 6th to the 9th. So it's a full week, Monday through Thursday. So registration will be opening here very soon towards the end of this month. So we're getting to that point now where we're going to really start to highlight and push for registration and attendees to go. What makes this year a little different, as we've been talking about throughout, if you've joined us before, we got 2 extra days in the week. The expo will still be the Wednesday and the Thursday as traditional, but the Monday and the Tuesday, as well as into Wednesday and Thursday, will be keynotes, technical sessions, and advanced training opportunities. So please reach out to us if you've got questions on Automation Fair, interested in attending. Reach out to your local Reynolds Company account managers or specialist members, and we'll be happy to talk all about it. And with that, we will turn it over to our guest presenter. We're very fortunate to have Mr. Armand Prezioso, Software and Control Manager with Rockwell Automation, join us today to talk about our PlantPAx and the 5015 IO. So with that, I'm going to stop sharing my screen, Armand, and you can take it over.
Thanks, Wayne. I appreciate it. Let me know if you can see my screen okay.
Yeah, I can see it.
Awesome. Thanks for the introduction. My name is Armand Prezioso. I'm a product manager for the Software and Control Business Unit. I'm currently the product manager for 5015 with this NPI project, this new release, and also product manager for 1756 IO. Here today, I'm here to talk just about 5015. It was released in the 5.2 release for PlantPAx, and that was with version 35 of Logix Designer. So this is an exciting part of the 5.2 release for the PlantPAx system. A quick overview. PlantPAx in the 5.2 release with 5015 was really built and designed around the process industry, right? So just to go over some of the key tenets for this, it is intended to be the basic process control system and a safety system. But this first release is not the safety system. So I just want to make sure I'm clear on that. This is not a SIL 3 system out of the gate. On release, it is just a basic process control system. Modules here can be used in simplex and or duplex. Each adapter pair can take care of about 24 modules. So at first release, when we have the 8-channel universal I/O, that gives you up to 96 duplex points or 192 simplex points. The architecture is high availability, redundant throughout it. That means the network section of it, the power, the backplanes, the I/O, everything is fault tolerant, redundant. And we have a high availability score when using redundancy of about 5 nines of availability. No wiring is disturbed if you need to remove modules or parts, adapters or power conditioners and so forth. Everything comes out from the Z-axis. And you can actually use remove and insert under power for all features of this product. You can even add a new backplane to it and add additional I/O while running. The modules can be mounted horizontal and vertical, which is good for application in panel space. Also, it can be an extended temperature range of -440 to +70. We also are conformally coding all these products, so we won't have the K variant of these products. It's just one catalog number that will be conformally coded and have the high temperature rating. At release, we'll have a copper port. I'll go over the details on that, but we will be having fiber ports come out in the near future. DCS focus is for universal I/O availability, right? Full of diagnostics. We'll have current sourcing on all 2-wire devices. Also, each channel is isolated, so any faults on one channel won't affect the other channels. And our network out of the gate will support PRP and DLR. Going on to the portfolio and what it looks like at release 1, as I mentioned, we'll have an 8-channel isolated universal module that can do analog in, analog out, digital in, and digital out. It also has HART available for the analogs. Also in the first release, down at the bottom, you'll see an AEN-FT, that's the Ethernet adapter. And then a new card that you've probably not seen in the past, which is called an ML media landing card. And that media landing card will be available in just RJ45 at release, but SFP you can see is in the future. Let's go back up though and talk about some of the other I/O cards that were under development. So we recognize that universal I/O is not the card of choice for everyone for their whole system, right? If you look at traditional I/O systems, you kind of already know what your I/O type needs to be, and you need higher density type modules, right? So we'll be looking at the IB16 and OB16 releasing in the future. And then we have a few other cards that we're putting down here that are on our roadmap. If you don't see it here, it doesn't mean that we haven't thought about it, but we're interested in hearing from you about what other I/O types you might want to see, right? Also, just to note again, this is released with version 35. It works with L8 controllers, including the L8P, obviously, for the PlantPAx system. And it also needs an 1756 AEN4TR to communicate to it. And I'll tell you why here in a few slides. I know I kind of skipped over the safety at the beginning. I told you the first release was not a safety system, but I just want to show you a little roadmap of what's coming in the future for Rockwell. I didn't want you to think that we're not going to be in the safety game. We'll start at the bottom, honestly, here with the SIL 2, SIL 3 controllers that we're developing. Those will be coming out soon, and at first release, they'll work with the 5094 safety modules, which are already available. And then as that product line develops, then we'll introduce the 5015 product into the safety platform. So just letting you know, I know we skipped over at the front. We said we're not doing it in the first release, but we do have future releases planned for safety. Going a little bit into the system overview about what all the different components are, I think it's important that we relay how this system is put together and what it's comprised of. So here I have showing how we can have different banks of I/O. On the next slide, I'll talk really about how those banks are configured. But we'll start from left to right, and when we look at just the adapter base, you'll notice the part number is A2A. That's similar to what we had in 1715. I try to keep the catalogs familiar to you if you're using the 1715 system, right? So the first adapter base there has two power conditioner modules. Those are highlighted with the the blue colors around them. And those power conditioner modules really take care of the backplane power for powering the modules, and they're redundant. You can notice you have an A and B power conditioner. In order to feed those power conditioners, at the bottom, there's a real slim RTB. There's actually two of them, one for each power conditioner. And that's where you bring in your 24-volt power from your system or from your location into power the 5015 rack. Back up to the top and to the right, you'll see the adapters, right? You'll notice there's no RJ45 connectors on these adapters. That's because we introduced the media landing cards, those MLCs below, and that's where you'll select what card you need for what media type. At first release, we mentioned that will just be dual RJ45s, so you'll be able to do PRP and DLR networks. And then in a future release, you'll have a fiber type SFP redundant MLC card. Over to the right, it's maybe hard to see. I wish I had a little laser pointer, but I'm moving my mouse around. I don't know if you can see that or not. Yeah. But there's something called a backplane interface card. And basically, those will be on each type of adapter base and quad IO base. They're the same media landing cards or backplane interface cards, but their sole purpose in life was to remove all the active components off the backplane. So on these backplanes, there's no active components. And by doing that, we're able to make those components redundant for the redundant comms that we have going down to the backplane. And it's able to be repaired and maintained as the system goes on, right? So those are kind of a new introduction to any of our customers that are familiar with Rockwell. It's a backplane interface cards. Down in the bottom left-hand corner, you'll notice a much larger RTB. And that larger RTB is a diagnostic input. Now, that is not diagnostic inputs for our cards or for your field devices like instruments and so forth. But that's how we're bringing in 16 diagnostic inputs for anything that's in your panel that you want to bring into your HMI or your PlantPAx system. Those diagnostic inputs can bring in things like door open, or if you have a temperature switch inside of your cabinet, you can hook them up to your 1606 power supplies for DCOK lights or DCOK contacts. You can hook them up to network switches that might have a DCOK contactor on it, or anything else that you might have in your cabinet as a dry contact. Those are not meant to be inputs, once again, for field devices to bring into your ladder logic code, but just diagnostics. Okay, moving on to the end of that adapter base, we have something called bank expansions. Those are optional. Those are if you want to have multiple banks. I believe I mentioned this before, but you can have up to 24 cards total throughout the system on that one adapter base using those quad IO bases to the right. So this bank expansion has, you'll see 4 cables. 2 of the cables are like the backplane comms, and 2 of the other cables are different from the backplane comms, but those are the bank power, right? So we're going to extend the power from the power conditioners down throughout those 24 modules that you can have. And the reason why they're not just one big cable for everything is because we want you to be able to keep the system running and change a cable if something was wrong with your cable or your cable connections, right? So in this case, if something was wrong with one of the comms cables, your second comms cable will keep the system running while you change out the first comm system. Moving over to the right, obviously there's the left and right to the bank expansion bases, so you'll see those there. And then the next base is the quad IO base, which can handle 4 modules. And those 4 modules can be configured either in fault tolerant or redundancy, or in simplex, where there's just one. The picture here, we have the first 2 UIO cards. Those are shown up in redundancy. You can see that there's an A and B right next to that RTB. You land your wires once, and we separate and have those modules go to both modules. So your field device is landing once. You don't have to land it twice in 2 different modules, right? You just bring it in once. Now, obviously, if you are designing something that has 2 field instruments, then you would land your 2 field instruments somewhere on those RTBs, right? The next RTB to the right of the 3rd quad IO module, that is configured in simplex. You notice the RTBs look alike, so the wiring is the same, whether it's a simplex or duplex system, right? And then to the right of that is a gray cover. That's just a blank showing that we have blanks available if you don't have wiring done. We'll stick on the RTBs. If you go all the way to the left, you'll see an RTB that says SA Power. I'll talk a little bit more about that as I get to the power section of the presentation of how you could land your 1606 power supplies with field redundancy devices. Underneath the RTB, you'll see a smaller shield terminal block. And that's so you can land all your shields from all your wiring, right? So you don't have to peel back your wiring, a 2-foot string and bring your shield terminal block to another terminal block and land it. You can land it right underneath the wires that bring in your field instrument device, right? Also, just to remind you at the top, you have the backplane interface modules at the top here, and there's 2 of them, one for each backplane comms channel, and there's an A and B, right? So once again, those are remove and insert under power. You can go ahead and exchange or change those out if something were to go wrong, and it has full diagnostic coverage, so you'll get diagnostic information on how those backplane interface modules are working. Going to move on to the next slide. This is just going over with you about the power for the power conditioners. Notice I have some 1606 power supplies. We have our recommendations for those power supplies and what model number to use. And then we're showing how those wire into, into the power conditioner RTBs at the bottom. Moving on to SA Power. Once again, we're showing how you can have redundant SA Power 1606 power supplies going into your FPRDs or your diode devices. You can bring that into your SA Power. Also, your dry contacts that are on those FPRDs, you could go ahead and bring into those diagnostic inputs on the adapter base that I mentioned earlier. A little bit about the banks. We discussed how you can have up to 24 modules. Well, those 24 modules in quad IO bases can be divided up into a total of 3 banks, and that's the max number of banks that you have, right? So on this display here, you'll see there are 3 banks. That's the maximum, and you can have a horizontal and vertical orientation. You do not have to make it 2 quad IO bases, 2 quad IO bases, and 2 quad IO bases. You can arrange that however you want to. I just did that for this example. Touching base on networking a little bit here. Yep. So notice on your banks here, you can do horizontal and vertical mounting, but keep in mind as you're doing these banks, imagine that you're stretching the banks out, and the cabling and RTBs have to be located at the bottom. You can't go into the back of the base and then into another quad IO base. Everything has to be kept on a straight line. You'll notice how we have the RTBs facing left on one side and right on the other side. That's to keep that flow of 1, 2, 3, 4, 5, 6 throughout the RTBs, right, or throughout the quad IO bases. So orientation is important. Into the networking, I mentioned at the beginning, you can do both PRP and DLR at first. So here's a good example of PRP. So I want to just mention again that you have to use a 1756 EN4TR. And the reason, because as we're introducing something called concurrent communications. If you're familiar with control logics and control logics processors and redundancy, you'll in the past you have used N+1, and what that means is your IP addressing for the primary processor base would be a .0, say, and then your secondary would be a .1. And on a failure of the primary to secondary, we would swap IP addresses. And during that time, there was a little bump, right? So that little bump may or may not have caused them customers any problems, but there was a bump there, right? We're recognizing that. With concurrent communications, you do not have to do IP swapping anymore. That goes away. So both EN4TRs, when configured for concurrent communications, will communicate to the 5015 adapters at the same time. And during a failover, you do not have to swap those MAC IDs or those IP addresses. That also gives you some speed of your switchover because you don't have to worry about that function, right? There's pluses and minuses to that, and I'll show you that on this next slide. If you are doing concurrent communications with a 5015 and you also have maybe some 5094 or 1756 IO in your system, those do not support concurrent communications at this time. So up in your processor chassis, you'll have to have 2 adapters, one EN4 to take care of the concurrent communications, and either an EN2 or EN4 configured in non-concurrent communications to take care of your 56. But they can reside on the same network, right? So you can still use the same PRP switches and same LANs, but just the controllers communicating through the EN4TR in concurrent communications to 5015. The same controller can communicate through the other adapter that's configured for non-concurrent communications to the 1756 chassis. This also works in DLR. You'll see this is still on the same ring in DLR, both 56 and 5015, but there are two adapters in the controller chassis, just like we had for PLR, for the PRP. Thank you, for the PRP network. So at this time, PlantPAx 5.2 supports version 35 and the L8 controllers, right? That would be the L8P for the PlantPAx system. And also it says version 35 of Logix Designer. So the key components here are PlantPAx 5.2, version 35 in the controller, your EN4TRs for the networking. That concludes the 5015 hardware portion of this, but I do have some other things to talk about, right? So a little bit about, I get why universal IO out of the gate. What about my traditional IO? Universal IO could be a little more expensive than traditional IO because you get higher density, lower density, more signal types in universal IO than in traditional IO. So the reason for this really is to reduce the risk of project execution, right? And you can do things maybe in a parallel aspect instead of a serial aspect, right? So if you look at traditional projects, right, it went from defining the size of the system and figuring out the networks. And once you had that in your instrument list of what everything that was going to be on the system, you would go ahead and start manufacturing enclosures. And then as you're manufacturing some enclosures, you might be doing some configuration of the system offline, right? And then finally you get your enclosures and you're doing a factory acceptance test, only to find out you have some changes that you have to go do. So you go back and adapt the manufacturing of the enclosures and change out some IO and then reconfigure some of your system and displays and go through that process again, and you get the installation and maybe there's some more changes and you go back through and make those changes again. So you're getting all these late changes that you have to do in your system, right? And that is really some project execution risk and some cost gets added to it. If you have a 5015 with universal IO, some of that goes down, right? You still have to figure out your network and so forth, but at the same time, maybe you're already laying out your system and you got your panels being designed. You're going through that process. You're manufacturing enclosures. Some of the stuff is the same, but you're doing parallel execution. But when it comes to the late changes, you probably don't have late changes as often because you have a universal card that you can change on the fly. So you don't have to go swap out cards. You don't know if you have to worry about room in the chassis to put more analogs in because there's less digitals now and so forth, right? You don't have to worry about spares as much either because it's one card that does all 4 signal types. So there's some efficiencies when you're doing it that way. Couple in a couple products from Rockwell, like the PlantPAx virtual image templates. Add in Logix Echo so you can do your configuration of your controller without having controllers present yet. And then using some of the design tools to lay out the system and so forth. Couple that in with what we're working on for a smart junction box, where we actually provide a universal junction box with either 48 or 96 IO points. Now your project execution looks kind of like this. While you're defining the size and laying out the system and networks, you can already place an order for manufacturing the panels. It's going to be about 10,000 IO. I'll purchase manufacturing enclosures that are already done. I can start configuring the system using Echo and the virtual image templates until you get your controllers in. So now you're doing parallel execution. You might not be the long tent pole in front of kicking this projects off. And then what universal IO on top of that, when you get the installation, you can be changing your IO types as you go along. So really the efficiencies, the late changes, you're getting a lot of plus and minuses that you won't have if you continue down the traditional IO. I'm not saying that universal IO is for everyone. There's still a need for traditional IO. We recognize that, and you'll be seeing more higher density traditional I/O from us in the future. Some life cycle benefits. Obviously, I mentioned some of those life cycle benefits, but one card, one universal I/O card, that's your spare card that you can keep in inventory. Your training for your employees is all the same. I'll mention a little bit here about wiring and efficiencies in wiring. So, in the past, you kind of need a secret decoder ring. If you're looking at 1756 in particular, there's differences between our hard cards, our regular analog cards, our digital cards. Depending on which card you select, you might have a 20-pin RTB, or you might have a 36-pin RTB. So, some of those can be different in wiring. Look at universal I/O for 2 wires, whether it's analog in, analog out, digital in or digital out. It's A and B only. Your plus is on A, your minus is on B, and you land those 2 wires, you're done. There's no secret decoder ring that gets you between that. Now, obviously, if you're doing 3-wire or 4-wire, you have to use the different pins that are available for you. But whether it's an analog in, analog out, digital in, or digital out 3-wire, it's all on the same locations. So if you wire things and then you have to change the I/O type later, you do it through an add-on profile, and you don't have to worry about going out and changing your wiring. Right? So some more efficiencies, and that helps with your life cycle management as well. Just to go over a few things, and I can show you some information on the web here. That our website is totally up and running. So on that website, you'll find stuff like a starter kit. We're offering this starter kit. We have been offering it since November Automation Fair last year. And that's to get some of these systems in your hand to start playing with, right? So you buy a starter kit from your local distributor. You only buy 2 of the 4 UIO cards, and then Rockwell sends you 2 free ones. That allows you to get a system on your desk, start playing with it before you start implementing it on your next project, right? There's a product profile. So if you want to look at some of the features of the system and read about it or look at it later, there's a product profile for you. There's videos and webinars just like this call we're doing today. I've probably done this 4 or 5 times, and they're on YouTube. They're on there's podcasts. There's all kind of stuff that you can listen to, including the YouTube channel that the Reynolds company has. There's videos on how you can change your EN4TR to concurrent communications. There's a video that's showing the add-on profile and how you change your channel from an analog input to analog output. All our product selection tools are up to date, right? So if you use Process System Estimator for your PlantPAx system, or you're familiar with IAB for your ordering, you can use the product selection guide to keep you out of trouble. There's how-to videos. I mentioned those earlier. And also all the technical data is up on the website, and working on the user manuals, which I should have those user manuals releasing maybe in the next 2 or 3 weeks, right? We're still working on that. And there's a barcode. You can scan that in the middle and get to the website to see some of that stuff. I think that's all I had. I went through that pretty quickly. The reason I went through it pretty quickly is I usually generate a bunch of questions. So if you haven't had a chance to type a question in yet, I'm not sure if we're seeing any, or if you still have some questions, I'm sure there's a lot of questions when I go through it this quick that you'd like to ask. So
please fill out in the question and answer section with Zoom. Just type them in. We'll go through them. In the meantime, Armand, can you touch on potentially anything that you guys are doing at Automation Fair regarding the 5015?
Oh, yep. Thank you. Yeah, at Automation Fair, we'll have several classes going on where you'll get to configure 5015. I have demo units that are all pretty much made. So you'll be using EN4TRs, configuring the communication for concurrent communications, and then going through and changing your inputs and outputs from analogs and digitals and so forth. So that'll be our first offering of the training course. So I hope we'll see you at Automation Fair. I'll be there presenting and running the labs as well. All right, the hardware appears to be direct wire. What kind of protection do cards have? Yep, that was brought up yesterday as well. So we do have current protection. So we'll detect like a short circuit and overcurrent, and we will turn that channel off and disable it and clear a fault, and allow you to go in to fix that, and then go ahead and reset that fault so you can get that channel back up and running. It's similar to what we have in 1756 with electronic fusing. but we're doing current detection, which is a little more accurate than electronic fusing, especially when you start getting to higher temperature locations.
And Armand, I know yesterday we got a lot of questions regarding 2-wire, 3-wire, 4-wire. Do you want to touch on that really quickly?
Yeah, I'm going to pull up, hoping to make you dizzy. I'm going to go back to the presentation here real quick and get to the RTBs. Yep, there you go. So as I mentioned earlier, for 2-wire devices, well, no matter what channel type they are, if you can see my mouse here, there's an A and B. So you got 8 columns in 4 rows, and it goes A, B, C, D, and 0 through 7 for your channels. So if I was doing a 2-wire device and we were current sourcing that through our SA power, right? So we're bringing power into the system through SA, and then I got a 2-wire device here. Let's say it's analog input, you're pretty much done, right? If it's digital input, it's A and B as well. Now, if you go to 3-wire, all we're going to do is use 3 different terminal blocks here. So your 3-wire, for example, might get wired to B, C, and D. And that would be true for an analog input, analog output, or digital. And if it's 4-wire, I believe it would be through B and C. Anyway, yeah. So if you're if you have any more questions about it, feel free to ask us. But the nice thing about it, no matter what signal type or what kind of wiring you're doing, 2, 3, or 4-wire, you'll be able to bring this into this terminal block, and you won't have to go off to other terminal blocks. Now, obviously, for 4-wire, if you're powering an instrument from a different power source, you would just bring that instrument power out to it if it's there locally, or if it's back in the same panel, then you would bring that power out to it. But we will supply 2, 3, or 4-wire connections on our IO platform. Yep, thank you, Leon. That's a good point. So for digital outputs that you aren't sourcing and you need higher current, we can also source a separate power supply and sync up the 500 milliamps. Right? With the inrush, I think is 1 amp for a certain amount of time. Yep, yeah, double it. So I forgot to mention that yesterday. Thanks, Leon. Any more questions come in the chat?
So far, no other questions. Just for you guys to be aware, we're actually launching this with Armand for the entire week. So for any of you guys that are in Houston based and want to be able to see that live, feel free to reach out to any of your specialists at the Reynolds company. We can kind of point you in the right direction. We're actually going to be at the North Center later today. We're going to be at our office on Thursday for our general learning series that we host there at the TRC North office. Then we're actually going to be at the PTU on Friday, which is the Houston E&H facility for the Process Training Center. And then we'll have this recorded. It'll be on our website with information. So if you guys are interested, if you want to learn more about the buy one, get one type program that Armand mentioned, feel free to reach out and we'll make sure to have conversations going forward. Thank you for the time.
No, that's it. Appreciate everybody joining us. And as always, reach out to us if you got questions after the session, and have a great day.